My name's Samir, and I'm the Professional Market Product Manager for Maple. And today we're going to spend some time talking about the new features in Maple 2021. Now, I spend nearly all my time speaking to our users. I help them to understand our tools, technologies, and services. I help them to use our tools to solve their technical problems, and I listen to their feedback and put that feedback back into the development process. Now, I'm always impressed by the sheer diversity of applications and the types of users that we have. We have users across the world in every single industry, in every single country. We like to hear about what you're doing with Maple. So let us know what problems you're solving in Maple, what you like about our software, and what improvements you'd like to see. That information is always welcome, and we always put that information into our development process. Now, this is a big overview of what's new in Maple 2021. As ever, we pack a lot into every single release. There are improvements across all parts of Maple. It might be minor tweaks to the interface. It might be performance improvements to specific functions and everything in between. There's always something in Maple to appeal to every single user. I'm also going to briefly mention a new tool that we've released, Maple Flow. It's a tool for design engineers. We'll talk about that briefly at the end of the main event. So without further ado, what I'd like to do is switch into Maple. And let's get started. I'm going to do the bulk of this presentation within Maple itself. You're currently looking at a Maple workbook. A workbook is actually a file container format. In a single workbook, you can have multiple Maple worksheets, images, data files, and so on in a single file on your computer. And you can navigate all of that content through the workbook navigator. You can password protect worksheets and so on. If you haven't already used workbooks, then I do suggest that you take a look at what they can offer for you. So, as I said, there's always more in every single release of Maple than we can cover in a What's New presentation. So we're going to talk about a select few features that appeal to me. Let's start off with some improvements we've made to the interface. Now, if you're a Maple user, you'll know that Maple has a rich technical documentation interface. Not only can you do your calculations, your math, your programming, you can also document your application as well. And this is just one example of a technical document. Maple's a pretty flexible environment, so a document developed by you could look very different to a document developed by me. But at the top, we have a title, a header graphic, images. I've laid out this worksheet with the use of tables. We have equations, results, and plots. We're always looking to improve the usability of the interface to make it easier to navigate between math inputs, to make it easier to create engaging presentations. And we've made a couple of improvements that I use all the time right now. It's now easier to insert new math inputs or document blocks within Maple. So if I left click on this, you can see that it's highlighted in blue. Now, in prior versions of Maple, if I wanted to insert new math inputs or new document blocks above this current math input, I'd have to use a keyboard shortcut. And I could never remember what that keyboard shortcut is. But now all I have to do is move my editing cursor all the way over to the right-hand side of this math input. It then gets turned into a bold cursor. If I press enter, I move that math input down and I create new math inputs above it. I can do that again here. So if I move the editing cursor all the way over to the left-hand side and I press enter, I create new math inputs. And as I said, this is much easier to use than the previous method of a keyboard shortcuts. We've also improved step-by-step evaluation in document mode. So this is a very simple example which demonstrates what this means. Here I have some definitions, X and Y, and then I have an equation interspersed with some text. In prior versions of Maple, if I pressed enter at this point, the editing cursor would jump to the start of the next text input. But now if I do that, if I press enter, the editing cursor jumps to the next math input. If I press enter again, it jumps to the next math input. So this means I can quickly update the entire content of a Maple document simply by using the enter key. That's a big improvement on the previous workflow. Let's move on and let's talk about the context panel. We introduced the context panel a few releases ago. It's the panel on the right-hand side. Some of you may have it closed, but you can easily open it like this. What does the context panel give you? Well, it gives you easy access to a lot of Maple's functionality. So here I have some math. If I left click on this math, you see context sensitive options populated in the panel on the right hand side. So I can quickly apply a math operation, plot the result. The context sensitive menu is truly context sensitive. So if I left click on this numeric matrix, you can see I've got new context sensitive options. So for example, I can calculate the eigenvalues of this matrix, the eigenvectors converted into standard forms. This is a differential equation where I've used dot notation over dots to indicate derivatives with respect to t. The context panel recognizes that this is a differential equation and allows me to solve it symbolically. This is a transfer function, a Laplace function, so a rational polynomial in S. Again, Maple recognizes that this is a transfer function and gives me appropriate tools to generate phase and magnitude plots, convert this Laplace function into other forms such as a state space model, a differential equation, or a zero pole gain model. I tend to use the context panel a lot for rescaling units, and we'll touch on units later. But for example, here I have a result that's in feet per second, but using the context panel, I can easily rescale it to, say, miles per hour, or even meters per day, just by using the custom units. The context panel can also be used for numeric formatting. So let's apply some sensible numeric formatting to that. So each release, we try to improve the intelligence and the smarts of the context panel and to help it recognize more parts of Maple functionality. So in Maple 2021, we've exposed more of Maple's functionality to the context panel. So here I simply have a vector that I've programmatically populated with some data. We've updated the signal processing menu, and we'll talk more about signal processing later with more and updated functionality. So there are windowing functions, various visualizations. I can transform this vector into different forms. There are filtering functions, features and statistics, various conversions. So let's pick something graphical. This is new functionality in the context panel, the peaks and valleys points. If I select that, Maple plots the data and identifies all the peaks and valleys as well. If I actually just want the numerical peaks and valleys, I can do that as well. And let's just identify the peak points. They're all there. Now, there is a command line version of this peak point algorithm as well, which gives you more options for filtering out various peaks, deciding what actually constitutes a peak, and so on. So this is an audio file I've read in. In fact, I'll show you how I read that audio file in because I don't think a lot of people know how to do this. If I go to Tools, Assistance, and Import Data, I can simply point to the audio file I want to read in, and Maple brings it into the worksheet and summarizes what it sees. So it gives me the sample rate, the number of samples per second, and the duration. So using the context panel, I can now view the Welch periodogram. Oops. And there's the frequency contents of that audio file. Let's move on. Let's look at some of the improvements that we've made to units. Now, over the last few releases, we've overhauled how Maple actually uses units. You can now use units in more parts of Maple, more functions understand units as well. And I have a number of examples here that I could show you. Let me show you this example. So this is a very simple application, but here I'm just going to calculate the total length of this parabolic suspension cable. This is the equation that describes the length of the cable in terms of the sag, D, and the span, A. I can specify values for certain parameters using units. Those are substituted into the cable length equation. And then I can use Maple's fsolve function, which is a pretty powerful numerical solver, to solve for the total span of the cable. So units flow through from parameters into the equations and right at the very end. And of course, using the context panel, I can rescale the results to my own chosen unit. Now, more parts of Maple can use units now. So the point plot command now understands units. So here I have a nested list. The first item in each sub-element is a time. The second item is a distance. And each one of those has units associated with it. So times are in seconds, lengths are in feet. And here's one neat thing I can do. I could actually mix units in this list. Now you can actually use the point plot command to plot this list. Previously, the point plot command wouldn't accept units, but now it does. We've also made some tweaks to the underlying infrastructure of Maple's various units packages. Numeric computation with units is now much faster as well. So here I have a pretty simple command, but it demonstrates some of the performance improvements. I'm simply populating a vector with 10,000 elements with this expression. So it's some function of the vector index with the units associated with it. In Maple 2020, this used to use a lot of memory and take about 10 seconds. So here you see the CPU time. In Maple 2021, this uses far less memory and is a good 7 times faster. That's a good solid performance improvements. Let's move on. So it's the continual improvements that we make to Maple's math engine that keeps people coming back year after year. Each successive release of Maple solves more and different types of equations than ever before, and we're continuously making headway. We've made many improvements to Maple's math engine, and this is just a selection of 3 improvements that appeal to me. Now, the integration command, int, now supports a method option for indefinite integrals. We've also introduced a new RISH method as well. And now we have a meta method which applies all of the integration algorithms and returns all of the results as well. So for this integration algorithm, this is the result. But if you use a different integration algorithm, the result, while mathematically equivalent, differs in its form. So Maple is recognized as the world leader in solving ordinary differential equations. And we're continually solving more and different types of differential equations. So here's one example that prior versions of Maple couldn't solve. Maple 2021 can. And now you can collect together differential equations in vectors and solve them with dsolve. Again, this is something that prior versions of Maple couldn't do. I touched briefly on signal processing earlier in the context panel. We actually have a big community of users using Maple for signal processing. It could be data from a test bench, it could be an audio file, or it could be image processing. It's a surprisingly large community of users. And this is a typical example. So this is an example of audio filtering. So here we've read in some audio. Again, Maple summarizes the contents of that audio. Using Maple's functionality, you can plot the time frequency characteristics of that audio file. So time on the x-axis against frequency on the y-axis. And there are various options which allow you to tweak the FFT size, the overlap size, and so on. And then you can generate an FIR filter. let's say, a bandpass filter and apply it to that audio file, and then replot the spectrogram, and you can see that there's a big difference in the contents of the audio file. You could then write out that audio file to your hard drive and use it in other applications. We've significantly added to the number of functions in Maple's signal processing package. And these are functions which have often been requested by our users. So there are new periodogram or spectrum estimation methods. There are new tools for calculating signal statistics, and so on. This is one command that I've been using on and off. I find it interesting. It's the music command, or the multiple signal classifier command. It's a pseudo-spectrum estimation method, but it allows you to estimate frequencies that standard approaches won't be able to give you. Let's move on to thermophysical data. So this is a package that we introduced, I think, about 5 years ago. It's a suite of tools for extracting thermodynamic and thermochemical data, as well as transport properties for pure fluids, fluid mixtures, and some solids as well. So, for example, you could load the thermophysical data package, extract the enthalpy of ethanol at a specified temperature and pressure. You could even generate a visualization. So, for example, a temperature entropy chart. There are many other tools in the thermophysical data package, but for Maple 2021, we've added standard atmosphere models. So these give you typical temperatures, pressures, air viscosities, and the speed of sound at a specific altitude. Of course, this doesn't account for local weather conditions. This is just the data that you would typically expect, averaged out over a period of time. So at an altitude of 3,000 meters, this is the expected temperature, air pressure, air density, speed of sound, and viscosity. If I change that to 10 kilometers, you can see this changes. So Maple supports 2 standard atmosphere models. The one we use by default is the US standard atmosphere. So we can also use this functionality in other parts of Maple as well. So for example, here we plot the temperature as predicted by the US standard atmosphere model as a function of altitude, the air viscosity, air density, and the air pressure. Now, there are many other features I could talk about, but in the interest of time, I'm not going to touch on them right now, but there is a lot there in the latest release of Maple. What I am going to do now is spend maybe a couple of minutes talking about a new tool that we've just released called Maple Flow. And this is MapleFlow. It's a free-form interface for doing calculations and analysis. And this is one of our standard MapleFlow applications. We have diagrams, text, looks like I'm using units, equations, and results. And if you look carefully, you might notice some Maple programming language commands. So here's a command from the plots package. There are a couple of major differences to standard Maple, though. Everything you see here is a container. So this equation is in a container. I can move it about on my worksheet. This text is a container. These images are containers I can shift about as well. You can see some dashed lines on screen. They actually delineate the boundary of my chosen page. So I think I'm currently set up to use a standard US letter format. So these lines would be the printed boundary. If I change a parameter, let's change this slightly. That change instantly cascades down the length of my MapleFlow canvas, and my results at the very bottom update to reflect the new parameter value. Now, what's unique about MapleFlow is that I can click anywhere on my canvas to place the grid cursor at my chosen point. I can start inserting equations, defining parameters, and using those in my calculations. I can also insert plots at any point as well and shift them about on screen. If I change the value of a parameter, that change is automatically reflected in these commands. If I want to see what my document looks like when I print it out, all I have to do is go to the File, Print Preview command, and there. If I place both MapleFlow and the Print Preview window on screen, you can see that the Print Preview is a faithful reproduction of what you see in MapleFlow. So it's as much of a calculation layout tool as it is a tool for doing math.